Welcome to Reading Time with Mrs. Eaton.
Lovely class. Oh, I miss you guys. I haven't made a little read aloud video for you in a while, so I figured I'd throw one out there today in case you are just wanting a little screen time with Mrs. Eaton. So we're going to read the reading that goes along with 3.1 about burning things. And if you are wanting to follow along and listen, feel free. I'm going to read out of my book. It's also on the computer, but it is this article, What Happens When Fuel Burns. And I'm going to give you a little read aloud today for it, so get excited, and yeah. And then if you want, there is a little video on Amplify of just burning a piece of paper you can watch as an ambiance or something. But I'm going to read you this now. So it says, most people burn fuels every single day. Fuels are substances that release energy when they burn. They are very important to us because we use the energy from burning fuels to do many things, such as run cars and buses, heat homes, and cook food. For example, gasoline is the fuel used in most car engines. When it burns, the energy it releases makes the car move. To prepare for a long trip, you fill your gas tank with gasoline, but after you drive for a while, the tank is empty and you need to fill it up again. What happened to the gasoline? Where did it go? When we burn something, whether it is a log, a match, or the gasoline in our gas tank, what we are actually doing is causing a chemical reaction. Burning gasoline may not seem like the kinds of chemical reactions that you have seen before. After all, chemical reactions cause substances to change into other substances as the atoms of the reactants burn to form the products. As the atoms of the reactants rearrange to form the products. When gasoline burns, it doesn't seem to change into a different substance. Instead, it seems to disappear, leaving you with an empty tank. If burning gasoline actually causes a chemical reaction to happen, then why doesn't your tank fill up with a different substance? Can a chemical reaction cause something to change into nothing? Lo, you're in my video.
Sorry.
Do you want to wave at them?
Yeah.
Say hi.
I want to get a coffee.
Cheers them with your coffee.
What's up, class?
They're not there. This is going on YouTube.
Oh, what's up, YouTube world? You're YouTube famous.
Woo! All right. So scientists began to wonder about this question back in the 1700s. Around this time, a French scientist named Antoine Lavoisier began studying what happened to the masses of substances before and after a chemical reaction. Mass is a measure of how much matter makes up an object. First, Lavoisier measured the mass of two reactants before mixing them to cause a chemical reaction. After the reaction had happened, he measured the mass of the products. Every time, Lavoisier found that the reactants and the products had the same mass. Through these experiments, Lavoisier helped come up with the idea we now call the law of conservation of matter. Matter cannot be created or destroyed during chemical reactions. This is because the atoms that make up all matter cannot be created or destroyed during chemical reactions, or ever, right? We can even we can break atoms. That's an atom bomb. Splits atoms. But the neutrons, protons, and electrons don't disappear. They just go somewhere else. We can never destroy them. We can never create them. This law tells us that all of the atoms that go into a chemical reaction must come out in the form of one substance or another. Chemical reactions cause atoms to rearrange into new and different groups, but the atoms themselves never stop existing, and new atoms never appear out of nowhere. So what does the law of conservation of matter have to do with burning gasoline? It means that even though your gas tank is empty, the atoms that formed the gasoline must still exist somewhere in some form. The only reason that these atoms seem to disappear is because the substances that form when gasoline burns are invisible gases. You can't see them, but they are there. And sometimes this isn't a good thing. Gasoline is just one of the many fuels that contain carbon. One of the most common fuels in use today is ethanol, a substance made up of groups of 2 carbon atoms, 6 hydrogen atoms, and 1 oxygen atom. Ethanol is made from corn and used as a substitute for gasoline. Like gasoline, ethanol is a colorless liquid at room temperature. When you burn anything, including ethanol, you are mixing it with oxygen. However, just having oxygen around isn't enough to make something burn. This reaction only happens at a high temperature. Burning reactions release energy in the form of heat and light, but these chemical reactions result in more than just energy. See the diagram below to learn more. So if we look at this diagram, right, it shows me I'm starting with ethanol plus, very hard to show on here. My screen doesn't want to stay up. Ethanol plus oxygen. Oh, goodness gracious. And then we have a chemical reaction happen, right? We have this little arrow, and then we're left with carbon dioxide and water. This we can see there's where the carbon molecules went, and then here's where the hydrogen molecules went, and then both of these are containing oxygen. So it says the chemical reaction that happens when ethanol and oxygen mix produces 2 substances, carbon dioxide and water, in the gas phase. Since both of these are invisible, colorless gases, it seems like nothing is left of the liquid that was in your gas tank. However, the atoms of the reactants haven't disappeared at all. They've only rearranged to form the products. The carbon dioxide and water produced by this chemical reaction enter the atmosphere whenever we burn ethanol or other carbon-containing fuels, like gasoline. In the recent past, humans have increased the amount of carbon dioxide in Earth's atmosphere by burning such fuels, resulting in widespread changes to Earth's climate. In response to these effects, scientists are working to find fuels that can release energy without producing carbon dioxide. We've talked about this already, right? How we have greenhouse gases that are produced from fossil fuels. So ethanol is also an example of, well, it's not a fossil fuel, but it's a fuel that has carbon, oxygen, and hydrogen. We burn that, and it always produces carbon dioxide and water. And so we're producing those greenhouse gases that are not good for our environment. Ooh. All right, last page. It says hydrogen fuel. Like gasoline, hydrogen is a fuel that can be burned to power cars and buses. However, unlike gasoline, hydrogen does not contain carbon. It is a substance made up of hydrogen atoms. When you burn anything, including hydrogen fuel, you are mixing it with oxygen. Still, having oxygen around won't cause something to burn on its own. This reaction only happens at a high temperature. Fires are hot and bright because burning reactions release energy. But energy is not the only result of these chemical reactions. See the diagram below to see more. So in this one, we start with hydrogen, just 2 hydrogens bonded together. And then plus, right, we know we have a chemical reaction happening, oxygen. And then this yields, right, these are our reactants, hydrogen and oxygen, and then they yield only water. We can see, right, they're not producing any carbon dioxide, they're only producing water because all we have is hydrogen and oxygen. The chemical reaction that happens when hydrogen and oxygen mix produces only one substance, water, in the gas phase. Since this is an invisible, colorless gas, you can't see it, which makes it seem like nothing is left behind by burning hydrogen fuel. However, the atoms of the reactants haven't disappeared at all. They only rearranged to form the product. The water produced by this chemical reaction enters the atmosphere whenever we burn hydrogen. Still, compared to the carbon dioxide that is produced when we burn gasoline, ethanol, and other carbon-containing fuels, the water produced by burning hydrogen has a less harmful effect on Earth's climate. If we can power our cars with hydrogen without producing carbon dioxide, then why don't more vehicles use hydrogen fuel? Unfortunately, the technology needed to use hydrogen as a fuel is expensive, and storing hydrogen fuel can be difficult. Also, the most common way of getting pure hydrogen is by separating it from substances that contain carbon. So, although burning hydrogen fuel does less harm to the Earth's climate than burning carbon-containing fuels, the production of hydrogen fuel is still a problem for scientists trying to reduce climate change. We're still seeing that we have carbon there. So, as we're trying to fix climate change more and more, they're doing stuff like learning about how to separate hydrogen and produce it without doing things that then are going to hurt our environment. So, there you go. That was our what happened when fuels burned. We talked about the law of conservation of matter, so make sure you know what that is, right? Nothing can be created or destroyed ever, ever, ever. And that's really important when we're looking at all chemical reactions. Whatever is on our reactant side needs to be on our product side because we cannot create or destroy anything. All right, miss you guys. And as always, click the link to subscribe, like my channel, comment. I've been blowing up on the YouTube recently, so make sure you're just keeping this content flowing. Miss you.